Every single cell that goes through our production line has its own unique production history.
Okay.
So we have tracked the temperature, the pressure, the chemical conditions of every cell, and we can track that into every panel.
Okay.
And we follow every panel into the field. So we have extreme traceability, and this allows us to do great diagnostic tests downstream. So we're really set up to scale to very large volume.
If you could say, what's the efficiency now?
Well, we're in the 10 to 12% range.
Okay.
You know, in the lab, we've published 16.4%. CIGS as a material theoretically can move into the high 20s. The highest it's ever been shown at NREL is 20%. So moving into the high teens is very possible, but we're in the 10 to 12% range now.
And I forget, on production, is it, Martin actually made a statement, if I forget the number. Is there a number you guys are talking about now? Or
well,
you know, per month, how many megawatts or how many?
We haven't announced a production, but we are scaling up rapidly. The manufacturing tax credit we just received from the Department of Energy and the Department of Treasury allows us to buy equipment faster. AB 1111 that we're talking about here allows us to buy equipment faster. We are designed both financially and technologically to scale to high production volume. We're past our R&D.
Oh yeah, no, I know that.
So the whole idea here is buy multiple lines of manufacturing equipment and scale as the market demands. We're really only limited by the market economics.
One thing again, could you explain the electrode part again?
Sure.
I didn't have the camera going then.
I absolutely can. Both the top transparent material that conducts current and the bottom transparent material, which also conducts the opposite charge of current, are relatively expensive for all manufacturers. Yeah. So you want to use less of it if you can, because then you have lower cost structure in your process. We use less by having a conductive foil, so the burden of having the lower cost material is displaced. In other words, we use less bottom electrode material because the foil underneath can carry that current, and we use less top electrode material because that current is carried from the top to the bottom of a second foil underneath.
So less material, lower cost.
Less material, lower cost.
And lower cost materials because it's not steel.
Absolutely.
Interesting.
Yeah.
Great. Well, thanks for your time.